Tonight we'll review one of the more challenging topics of Algebra 2, which is probability. Challenging because you've got to know the rules of probability, when to apply them, and you have to read carefully. So the first rule of probability is the multiplication rule, the probability of A and B. Now remember, our symbol for AND is the upside down U. So the probability of A and B is the probability of A times the probability of B. So the minute you see AND, that means to multiply. Now this is the formula as long as the events are independent, that the first event does not impact the second event. If the events are dependent, the first event plays some sort of role in the outcome in the second event, then it is the probability of A times the probability of B, given that A has happened. Which leads us to our next rule of probability, the given. The probability of B given A, we can get that from this formula up above just by solving for the probability of B given A. So if we divide both sides by probability of A, we're going to be left with the probability of A and B, both of them, divided by the probability of A. And then our last rule of probability, the addition rule, aka OR, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Now, if the two events are what are called mutually exclusive, then you don't need that minus probability of A and B. It would just be zero. There is no overlap of event A and B. But it's a good idea to just remember this formula and use this. And if there is no overlap, then you can just have a minus zero at the end. So let's try this out. There are 200 students at Hilton High School. 355 of the students are seniors. 280 students have parking passes. The probability that a student selected at random is a senior or has a parking pass is 461 out of 2,000. What is the probability that a student selected at random is a senior and has a parking pass? So first thing that I always advise is change these sentences into equations. So the first one, the probability of me picking a senior is going to be 355 out of 2,000. The next sentence tells us 280 students have parking passes. So the probability of me picking a student with a parking pass is 280 out of 2,000. The next sentence is the probability of a senior, picking a senior, or having a parking pass is 461 out of 2,000. What is the probability that the student selected at random is a senior and has a parking pass? So once we put those sentences into equations, it makes it a lot easier to match up what we're doing, what one of these rules we're using. And in this case, it's clearly this one, because we know probability of A, which is senior. Probability of event B is the parking pass. We know this, the OR, but we don't know the AND. So I'll just plug in what we know into the formula. Senior or parking pass is 461 out of 2,000. Should equal probability of a senior plus probability of parking pass minus the probability of both. Now over on the right, I'll just add these two fractions together and get 635 out of 2,000 minus the probability of both is supposed to equal 461 out of 2,000. So then I could do 461 minus 635, which is negative 174 out of 2,000. which will equal the negative probability of both, of senior and a parking pass, which means when I divide both sides by -1, the probability of picking a student that is a senior and has a parking pass is 174 out of 2,000. Next, we'll put our rules into play with a two-way table. So we've got a survey was done of males and females what their favorite type of music was, techno, rap, or country. So the first question about the two-way table, what's the probability of picking somebody that likes rap? Well, there's 65 students out of 200 that said they liked rap. There's my answer. We could reduce that if we wanted. I'm not going to. Next probability, female and country. Female and country, where they overlap is going to be my answer. So they overlap at 27. So 27 out of 200 students are female and like country music. Now, if we were going to do this using our probability rules, I would need to do the probability of picking a female times the probability of picking somebody that likes country given that they are a female. We're assuming the events are dependent on one another. So notice the probability of picking a female is 106 out of 200. And then country, given that they are a female, well, there's 106 females and 27 of them like country. And when I multiply these two fractions together, 106, boop, boop, leaves me 27 out of 200. My next question, probability of picking a female or a preference of country. Well, I've got my female and my country circled here, so I'm just going to add up all of these numbers in my bubbles. So 54 plus 25 plus 27 plus 18 will give me 124 out of 200. If I were to use the formula, I would do probability of female plus the probability of country minus the probability of female and country. So the chance of me picking a female is 106 out of 200. Chance of me picking somebody that likes country is 45 out of 200. And then I'm going to subtract the people that like both, that are both female and like country, is 27 out of 200. And if you add and subtract those fractions, you're going to end up at 124 out of 200. Next, the probability of picking somebody that likes techno, given that they are a male. So I'm only looking at the males, of which there are 94 of them. That is my denominator. Of those 94 males, how many of them like techno? Well, 36. And there's my answer, 36 out of 94. If I were to do the formula, I would need the probability of techno and male divided by the probability of picking a male. Now notice if from my table, the number of people that like techno and are males are 36 out of 200. And the probability of picking a male, well, there's 94 males out of 200. And notice the 200 in both denominators, boop, boop, leaves me the 36 out of 94. And lastly, are gender and music preference independent? So we're just going to pick a gender. I'll pick males. And multiply by one of the music preferences. I'll go with rap. And see if that multiplication is the same as the probability of picking a male and likes rap. So the probability of picking a male is 94 out of 200. The probability of picking somebody that likes rap is 65 out of 200. And then picking a male and that likes rap as well. Well, here's my males. Here's my raps. They overlap at 40, so that would be 40 out of 200 are males that like rap. And then we're just going to see if that equation is true. If it is, they are independent. If they are not equal, they are not independent. They are dependent. And when you multiply out the left side, it does not equal the right side. So these two events, gender and music preference, are not independent. They are dependent.